My DIY day, August the 29th. What I would say about this video, please watch, because lurking in your consumer unit could be a problem, that you may not be as safe as you think you are. This is really a follow-up to a previous video where I was installing an LED floodlight in my garage. Your consumer unit, tucked away under the stairs in a cupboard somewhere, is full of breakers, circuit breakers, which protect the circuits, various circuits, from overcurrent. It's not only useful for protecting from overcurrent, obviously it stops damage to equipment, it stops fires, it protects the cables, and it gives you a means of isolating them when you're changing a bulb or whatever you're doing on that circuit. So that's fine. But more important in there, arguably, are these devices. Now, the generic term is an RCD, a residual current device. And the idea is that if your equipment is defective and the live side or even the neutral side is connected to earth accidentally, it will trip. And that means if you touch the live, within milliseconds, it will trip and remove the power. How does it do this? You don't need a great deal of detail, but if you just think about this, all the power that comes up through the live, the current, comes back through the neutral. So it's balanced, it's always balanced. But if some power goes to earth, that balance is lost. And this device very cleverly will notice that. If the current to earth is more than 30 milliamps, it will trip. You can buy clever ones now, which you can put at different levels to give different levels of protection. But the standard one like this is 30 milliamps. So in your consumer box there, you will have these protecting your lighting circuits and your various distributions, and they're typically split between maybe downstairs, upstairs, etc., etc. So that's it, you're protected, aren't you? Well, not necessarily. When I look in my consumer box, I've got all the protection you could want in there, but it's about 20 years old. So the RCDs in there are type AC. Now this is important. Remember my LED light? When I switch it on, this one trips. The ones in my consumer unit do not. When I replaced this with a normal breaker, the ones in my consumer unit still did not trip. However, when I press the test button, they work. Kind of strange. Anyway, from my last video I had loads of comments, and I have to say I had some very good comments from some electrical people who really know what they're talking about, and it opened up a can of worms for me. There's a number of things about this that Joe Public maybe don't realize is happening. Okay, so the breakers, the RCDs that I have, the type AC, which is probably, if you're in an older house and it hasn't been rewired recently, it will be what you've got. There is a problem. They work with AC power only and simple loads that we used to have in our houses. Time has moved on. We have now switching power supplies, such as the LED, computers, many things. There are even in washing machines variable speed drives. There could be DC power gets back onto the circuit due to the way some equipment now works. That could mean tripping when you don't want it, like this, or worse still, something you have in your house has just been fitted subsequent to your power distribution, your consumer box being put in, could be putting DC back into your system, and it will have the effect of disabling your residual current device. And the official term you see online is blinding. The DC power goes through this device. It doesn't trip on it. It only trips with the AC leakage, but it has the effect of basically disarming it. It saturates it and it doesn't work anymore. So, easy way around this. I'm not saying everybody should rush out now and buy new breakers, get an electrician in. But what it does say to me is, and probably you don't do this, I didn't, once every 3 months, we should press this button. Because if there is something disabling it, if you have equipment you've installed later, such as a brand new washing machine with a variable speed drive, or a large number of computers, or a large number of LED lights, it may have disabled them. If that is the case, you would need to speak to an electrician, get an electrical company in, and they would need to change them for a more suitable type. Now, there's very strict rules under a British standard about what types should be fitted in houses. And it's all dependent on the loads you've got. But the problem is, if in my case, 20, 30 years ago, the consumer unit was put in, these switching supplies, variable speed drives in washing machines did not exist. But nobody's told me, hey, you better have that looked at again. So there's something to be said for having that checked out. So potentially your RCDs are being blinded by the modern equipment you've installed in your house. I've checked mine, they are not. They are still working. So it's there, it's out there, it's in technical papers, and electricians, good electricians commented to my last video to say that this is a problem, and they would normally fit a type A as a replacement. However, my type A, I can't use it with those lights from Wicks that I bought. They seem to pick up something which is not necessarily wrong, but they pick up something and they trip. So there are more complex ones, type F and type B, that I would probably need to use. But that brings me to something else. But when I do research, a lot of people complain that when they fit these LED lights, they trip the circuit breakers on switch on. Even though, if you look at the current they take, it's well below. The problem is, these lights, especially if you've got a few of them in a string, they have a high inrush current. So for about 1 millisecond, as you switch it on, the current goes well above the rated current. There's examples I saw online, 16 times, even one bad one, 60 times the current. For 1 millisecond, the current is very high. And if your breaker's acting fast enough, it will trip, quite correctly. So there's a case here of awareness. And what I've discovered is if you go for a good name, a well-branded type of LED light, they are designed in such a way that these inrush currents are far smaller. I saw a Philips one, which was hardly any inrush at all. It had been designed carefully with that in mind. And most likely, if I had that Philips one installed in my garage now, I wouldn't be having the trouble with this either. Anyway, my lights are installed. I've got 6 of them in a line, and they do not trip my type AC RCDs, but even one trips this type A. So what am I going to do? Well, I'm now going to order up the best type of RCD I can get, which is going to be a B, and I'm going to put that in and see if that still provides the protection. Well, I'm sure it will provide the protection, but will it still trip with these Wicks cheap LED lights? It's interesting. Now, obviously, you shouldn't do anything with your consumer unit, etc., unless you are qualified to do so. But actually opening it up and testing this once every 3 months is a very good thing to go. Just be sensible, just be safe. There shouldn't be anything you can come into contact with, but simply pressing that button for test once every 3 months would be a very good thing to do. Because if these are blinded and you do come into contact with a live terminal, instead of it tripping and probably allowing you to survive the electric shock and not be electrocuted, it could be blinded, in which case it will not offer any protection. Anyway, I hope you found this interesting. I hope you will do the test to make sure that yours aren't affected, and I hope you've got a bit more awareness now of the different types of residual current devices that are available. I'm certainly going to be testing mine in the future, and I'm probably going to upgrade all the ones in my consumer unit anyway.